Okay, we're going to start today with this problem right here, and I'm going to give you a minute. Everybody give that your best shot. After about a minute, we'll resume and see who knows what to do. All right, and now I hope you multiplied it by 8x in all three spots. You could have multiplied by 16x, but you wouldn't have needed to. Okay, now I'm going to cancel out this 8, and I'm going to cancel out this x, and I'm going to cancel out, well, the 8 and the 2. I could really replace the 8 with a 4 times 2, because if you can factor it, you should. The 4's cancel, and there I have 2x squared equals 8 plus, 2x squared. All right, now this is weird. I feel like there's something wrong, but I don't know. Well, I see it. It's a 4 here. Am I correct that that's a 4 there? Because I canceled my 2's, not the 4. There's a 4 there. I think I've got it straight so far. Okay, good. Sorry, a little distracted today. It's kind of an unusual day. So now I'm going to make this be, I'm subtracting 2x from both sides so I can have a positive lead term. So 2x squared. Question? Okay. Equals 8. I think, is that right? Seems pretty easy. Okay, now I could, I could get this over onto one side and make it equal 0 like this. 2x squared minus 8 equals 0. That'd be okay. And then if you can factor it, you should kicks in. But I actually think it'd be easier to just divide both sides by 2 right here. Because do you get, then I have x squared is equal to 4. And that's pretty easy. That's definitely going to be factorable. I subtract x from both sides. I got x squared minus 4 equals 0. So x plus 2 and x minus 2. And I'm, a little shaky on this, not feeling like I'm positive I'm right. So then how could I make sure I'm right? I'm saying basically that the answers are x equals 2 and x equals negative 2 and 2. Those two answers. And if I really think they're right, I should maybe go back to the original problem and check them. And since I've made a mistake already this hour, I'm going to make sure I didn't screw that up. And I'm going to put in a 2 here, and a 2 here, and a 2 here, and see if it really works. 1 is equal to 1/2 plus 1/2, and that is equal to 1. Yay. And I'm going to guess the negative 2 is also going to work. If I put in a negative 2 and a negative 2 and a negative 2, that's going to be negative 1 is equal to negative 1/2 plus negative 4/8, which is also 1/2. And so, yeah, negative 1 equals negative 1. I now know that I'm right. Those are my two answers. Okay, that was kind of complicated. Why was that there? Why were we even doing that? Because today's new stuff is supposed to be about rates. Okay, and I'm going to see, I'm looking at the time, I'm deciding that I don't feel like today is the best day for me to try to teach you some kind of complicated rate problems, and we are ahead of where we have to be today. So we're going to just focus on the 7.1 to 7.2 quiz, which will happen in just a minute here. And we'll talk about doing these application scenarios where you're solving rational equalities. It's a little too dense for a day like today. All right, so instead, let's talk about what I taught you yesterday about horizontals and verticals. And here is a typical question. 3x squared minus 6x is on the top. And x squared minus 4 is on the bottom. First off, I'd like you to figure out for me, are there any horizontal asymptotes? Are there any vertical asymptotes? And I'd like you to just to show me that you can get me 1 point on an XY chart. I'd like you to just put in 1 into the function and see what you get. Okay, I'm going to pause for a second and see if you can figure out the horizontals. Remember, there's rules about bob, sob, and bot. Okay, And then the verticals. That has to do with the denominators. Oh, and there's one more thing. There might be a hole. And if there's a hole, tell me where that hole is. One thing that we should probably do a little more thoroughly, let's say that you figure out that there's a hole at 3. I'm not saying there is, but I'm saying, let's say you figured out there was a hole at 3. You can figure out the other part of the hole by putting this in the function and figuring out what it gives you for the y value. I'd like to be a little more intentional about that part today. Instead of just saying there's a hole, we're going to find out exactly where on the graph the hole would be. Okay? So, it's not 3. But figure out what the x value of the hole is, and then figure out what the y value of the hole is. So the last thing was, you're finding me a point. When you stick in 1, what do you get? All right, and if you haven't already figured this out, there's definitely factoring that can be done here. Okay, pause for a minute, and then once I feel like most of you guys are ready, I'll check, and then I'll resume, and we'll go from there. Okay. If you can factor it, you should. See how there's a 3 here and there's a 3 there? Oh, there's also an x here and there's also an x here. So 3x comes out and you have x minus what? 2. All over x plus 2 and x minus 2. Coincidence? No. Because look at those. What do? They cancel and they make a hole at 2. So 2, not negative 2, but 2, if when it put in here, would have caused this function to crash. So 2 is a hole. 2 comma what? Well, I take what's left over here, this part of the function, and I stick the 2 in there to see where exactly the hole should be. So if I have a, oh, wait, change this to a regular marker. If I put the 2 there and there, then I have 6 over 4, which can be reduced, of course, 3 over 2. Raise your hand if you had the hole in the right spot. Okay, good. Then, horizontal asymptotes. The rules are bigger on bottom, in which case it's y equals the outside. Bigger on top, which would mean no asymptotes, horizontal ones anyway. And same on both, which is y equals a ratio of the lead coefficients. Which kind was this, Sam? Was this a Bob? Sob or about? Okay, same on both. So it's y equals lead 3 and 1 makes 3. Raise your hand if you had horizontal at 3. Okay, good. And the vertical asymptote is whatever makes the bottom 0. Very common mistake here to say, oh, so there were 2 things, x equals negative 2 and x equals 2. But the problem is that it can't be both. And when they have, and I know this is complicated, but when it's like this, when there's one on the top and one on the bottom, then that was a hole. It's only if there was another x minus 2 on the bottom, then it would be a hole and an asymptote at the same time. This is not that scenario, and in that scenario, the asymptote would win. This is not that scenario. There was just one thing that canceled. It's a hole. So if it's a hole, it's not an asymptote. Okay? So this one only had one vertical asymptote at negative 2. Then I asked you to put in 1 point. Matilda, when you put in a 1, what did you get? Raise your hand if you had 1 comma 1. Okay, good. So then if you were to graph this, you would obviously start with your horizontal and your vertical asymptotes. And at 1, 1, you'd have a dot. You'd need a few more dots though, right? From my experience, if you have 2 curves, you need at least 3 dots on each curve. Because if I just say, here's a graph, and I give you 2 dots. Can you tell where the curve goes? No, not at all. But if I give you 3 dots, all of a sudden you're like, oh, I see, the curve goes like this. So for each curve you have, you need at least 3 dots. So that means you probably need at least 6 points, and more is better. If I give you a whole bunch of dots, you can tell exactly where that thing goes. More is better. All right, so you'd have lots of dots on here. All right, so what I'd like to do is I believe that I did not cover everything that is on your little quiz you're about to take, but I want to put you in groups, and that's going to be rows 1 and 2, which are by the window here, you're going to slide next to each other 6 inches apart. And this little quiz is what you're about to complete. And in a moment, you're going to be grading it, so don't worry about the grading for now, obviously, but you're going to be just finishing it as best you can with the kid next to you, double checking with each other to feel like you've got it right. Make sure you do a really good job in the graphing part. That's going to take a while. And then there's a part B on the back side, this page right here. Okay, so rows 1 and 2, I'd like you to slide next to each other and get to work on that quiz. And rows 3 and 4, slide next to each other. Up as a partner, work with a group near you. You guys work together. You guys work together. You guys work together. And you guys work together. You can work in a group of 3 right there. Okay. At the end, I will be giving the how to do all of these. So this is a work time here for the next few minutes. Okay, I want you guys to slide your desks back. I know you're not done. It's okay. Finishing that is your homework for tonight. Now you've got a good head start on it, and you've gotten help from a kid next to you, and you should be able to easily finish that up as part of your homework for tonight. Now let me use the rest of our time to teach you some more stuff about rationals. So again, we will revisit this tomorrow. Your job, have it done by then. Okay, same thing on this page. So get to this page of the notes, purple color, and we have 2 different kinds of problems here. Look at the top one and look at the bottom one and tell me there's 2 major differences between the top problem here and this bottom problem here. Tell me one thing that's different about them. Yes, sir.
The bottom one's an inequality.
An inequality. That means that at the end, on an inequality, you always end up with a number line and a couple of answers, and you got to figure out where it works. Let's say I know that the key spots are like 2 and 3. Maybe those are because there's asymptotes there. Then you got to figure out, does it work in here? And you check a number. You take a number, you stick it in, and see if it works. And then you find out, oh, it works in there. And then maybe it also works here, but it doesn't work there. All right. On polynomials that are like quadratics like this, also remember that you're going to get it set equal to 0. All right, so that's one difference. One of them is an inequality, one of them is an equality. This just has typically 2 answers because it says equals. Versus if it says less than or equal, you'd have a whole range of answers. But this kind will just typically have 2 answers. So again, if you've got a less than or equal to sign, you treat them differently. All right, so on this kind, it does say the steps over here, and you might want to refer to these on the homework for tonight. Your first thing you would do is, I don't like to say cross multiply, I like to say clear the denominator, because really, you only have to multiply both sides by x plus 1, and it's actually a lot easier than cross multiplying. So I'm going to multiply both sides by x plus 1, and that makes this go away. And then, well, that looks like it's going to turn into a quadratic over there, and it does. And then you set it equal to 0 by subtracting the stuff from the other side. So let's just get this going. It's x squared plus 5x plus another 1x makes 6x plus 5. And then I still have 2x plus 17 here. Now I'm going to subtract the 2x from both sides, and I'm going to subtract the 17 from both sides. It's a double step, aka dubstep, popular a few years ago. I know. All right, painful. Dad jokes. You like that one? All right. So negative 12, I think. Can anybody verify they got the same thing as I did? All right, good. Then, if you can factor it, you should. And then you end up probably figuring out that it factors. I'm guessing 6 and 2 make 12, and they also can make a 4. So you'll get your 2 answers pretty easy. Why isn't there a range of answers? Because it's not an inequality. All right, now let's go down to the inequality down here. For this inequality, the first step, well, it says over here, set one side equal to 0. You cannot clear fractions on this kind. Why? If you multiply both sides by a variable, the thing is, you don't know which way to switch the sign anymore because you might have just multiplied it by a negative. Now, I could have just said, you can't multiply by variables on this kind. But I'm trying to explain, do you get if I multiply by 5 on both sides, I would not switch the sign if I just multiply by 5? But what if I was multiplying by a negative? Do you remember that that switches the sign around? Okay, well, when you multiply by a variable, which you might want to do to clear that fraction here, if you multiplied by a variable, it goofs that up. You can't tell whether to switch it or not. And so it's the law. You can't multiply by a variable on this kind. So what do? As it says, you set it equal to 0. So what you do is you simply subtract 1 from both sides. Now that seems easy until you realize, dang, I'm going to have to get a common denominator here. Now, it's not that hard if I just tell you, you've got to get a common denominator, but you've got to notice that yourself, like on a test. And so I'm multiplying this by x squared plus 1 over x squared plus 1, because that's like multiplying by 1, okay? And now, it's got a common denominator. All right, I'm going to just say from here, you would have to get this thing to have any zeros, things that make it equal to 0, which is things that make the top 0. Okay, those are the x-intercepts. Maybe you take a note, makes the top 0. And the vertical asymptotes. Do you remember how those make the bottom 0? Makes denominator 0. So when you've got this all put together, you then analyze and see what would make the top 0. Then you figure out what would make the bottom 0. And you put all of those on a number line, and I have to trust that I taught you already how to figure out whether intervals work. So let's say by now you might have figured out there's no way to make the bottom 0. Do you get x squared plus 1? There's nothing you can put in that would make the bottom 0. Okay, so there is nothing that makes the bottom 0, but there is something that makes the top 0. Maybe there's even 2 things that make the top 0. Once you figure out what those are, let's say it's 2 and 5. I'm not saying that's correct, but if it were, then you check 2 and you stick 2 into your equation and see if it makes it equal 0, which it will. So that means it works. And then when you stick in the other number, like 5, it'll be a 0, so it'll make it equal 0, so it'll work. And then you'll have to test something in between. All right, I'm leaving the rest. That's something you're supposed to already know how to do. So now we're going to go look and see what I want you to do for homework. Number 1, I want you to finish that quiz that we started in class with a partner. That should be the easy part. And then I would like you to skip over this kind of question. Skip over this kind of question. We'll talk about it tomorrow. And of your homework, I want you to do one of these kind that are easy, where you just clear the fraction by multiplying by the denominator. Solve one of those. Let's do one more because it's a quadratic. You'll just multiply on both sides by x squared plus 1. And then I want you to try one of these tougher ones where you can't multiply by x plus 2 on both sides. You just find whatever makes the top 0, whatever makes the bottom 0, and then you figure out and test intervals to figure out, oh, it's like from here to here. That's not the right answer, but something like that. And I'd like you to do one more like that one. And that's it. None of the other problems. There's a lot of other problems in this. I only want you to do the ones I've told you to do. Yes?
On the previous page, which problems did you want us to do?
The only one that I circled, which was, since somebody, problems 1 and 2 on the first page, and problems 7 and 9 on this page. Okay, that's it. 4 problems plus that quiz that you started in class, and that's all I got for you for today.